Good evening. Welcome to MIT, to the many new faces. My name's Stephen Barrett. I'm on the Faculty of Aeronautics and Astronautics here at MIT. I'm the co-chair of the Harvard MIT Geoengineering series, and it's my privilege to welcome you to a special event tonight, which is a public debate on the future of geoengineering. Now, we have a fantastic lineup here of academic leaders in their fields who are going to debate this issue, and I'm not going to introduce them. I'll leave that to our moderator, but I will introduce our moderator. So we're very lucky to have Oliver Morton as our moderator. He's an editor at The Economist currently. He's interested in scientific knowledge, technical change, and their effects. He's also worked as a senior editor at Nature. He was the news chief there. He's worked as editor of Wired UK. He contributed to The New Yorker, The New York Times, National Geographic, The American Scholar, and many other publications. He's written 2 books and has a third on the way. His first book was Mapping Mars, Science, Imagination, and the Birth of a World. His second book was called Eating the Sun, How Plants Power the Planet. Writing about this book, John Turney said that it contained, and I quote, everything you could possibly want from a popular science book. There is wonder here, there is intellectual excitement, clear explanation, lyrical writing, and much new insight into how the world works. Now, he's currently working on a third book called The Deliberate Planet, which is about geoengineering. And he's been doing that for some time and has developed a strong knowledge of geoengineering. So with that, please join me in welcoming Oliver Morton, our moderator for this debate. Just before I hand over, there'll be a reception after this debate just across there. Restrooms are outside. And if there's a fire alarm, I'm going to leave, and I'd advise you follow me.
Well, thank you very much, Steve. That was going to be my flight attendant thing too. Yes, the doors, they're at the back. They're where you came in. That's all well and good. Thanks very much for coming. It's a great turnout, and it matches the greatness, I hope, of the panel. And we'll be starting off with a few sort of like personal reflections from the panel. I might throw a few questions around up here, but we'll be opening it up to the audience. It's not going to be structured as an adversarial debate. There's no sort of like, well, there are far more than 2 sides to this question, so we're not going to be, we're not trying to decide a motion or anything. We're just trying to have a pretty full discussion of the issues ahead of us when we're discussing geoengineering. But I wanted to start with a trick borrowed from Rob Socolow. I saw him do this at a meeting a while back, which helps us set the frame for how we're going to think about this. Interesting to see how it goes. Don't feel obliged to participate in this, but please do participate. Could you raise your hands if you think the risks of climate change pose a deep, serious problem to civilization? Yeah, I thought that was going to be a large majority. Now, actually, keep them up. Now put them down unless you also think that abandoning fossil fuels is an extremely difficult task.
What?
Yeah. Okay. Yeah, you're holding it up for yes. For yes, climate change is difficult. Now keep holding them up if you agree. Yes, getting off fossil fuels is very, very hard. Okay, few went down, but most didn't. So this puts you in what Rob would call the yes camp. Yes, it's a big problem. Yes, the solution, which is most frequently talked about, is a very difficult one. Now, in this room, it seems that we're all largely aligned with that. We have to bear in mind that most of the debate on climate change is not aligned with these 2 questions. Most people will have difficulty with either accepting that climate change is a real serious problem, or they will have difficulty with accepting that getting off fossil fuels means more than a few solar panels and windmills. So we put ourselves in this area, and this is the area where we find it reasonable to at least think possibly about geoengineering. But that is not, I would stress, the only thing that you can think about if you are going to give your affirmation to both climate change is a real problem and getting off fossil fuels is difficult. There are other responses you can make within that quadrant of the possible 4 quadrants you can divide the world into. You could become a deep green, you could argue for very deep social changes, there are various other responses. But again, the important message here is you've already selected yourself in this group into a minority within the climate change debate. And that's what we're going to explore tonight, this evening. I'm going to call first on the panelists, as I said, to make a few introductory remarks about who they are and why they're interested in this topic, and I suppose to some extent what they bring to the table. I'm going to move from furthest away to closest to me, so I'm going to start with Stephen Gardner. I should add that you should assume that everyone on the panel except me is at least one professor and possibly 2 or 3 professors. Stephen is, I think, 2 professors at the University of Washington, Seattle. He's the author of a magnificent book about the ethical conundrums of climate change called A Perfect Moral Storm. This book would be a wonderful book, even if it did not have one of my favorite chapters in any recent climate book, a chapter which understands the issues of climate change entirely through a close reading of the beginning of Sense and Sensibility by Jane Austen. You would think this was not possible. It's not only possible, it's also magnificent. So, Stephen, if you would just start us off, please.
Thank you for that overwhelming introduction. I wish I could think of some Janeite witticism offhand. So, we were asked to say why or how we got started thinking about geoengineering. And in my case, it's because I started through an interest in ethics and climate change more generally. And then shortly after, Paul Crutzen published a famous article which kind of opened the floodgates for talk about geoengineering. I was asked to be on a panel at the AAAS. And the 2 things that struck me about Crutzen were, on the first thing was that his argument was starting for the assumption that we faced a profound problem of political inertia. It's clear what we should be doing, and we weren't doing it. And therefore, geoengineering, particularly sulfate injection in the stratosphere, was on the table. And the second thing that struck me was that the particular arguments that he therefore started to give looked like overtly ethical kinds of arguments, and some of the concerns he had with the whole situation did involve ethical issues. In particular, there's a general framing which is common in the early discussion of geoengineering, as geoengineering is a kind of lesser evil solution. I was interested in the inertia question because a lot of my work at that point was around trying to understand what kind of problem the climate problem is, what kind of challenge it poses to us. And I thought part of the answer to that question was that it's a real ethical challenge. It's a kind of challenge that confronts us, and in particular the kinds of institutions we have, with threats that they're not very used to dealing with, and which is very convenient for us to ignore or downplay. And more specifically, this interest in the lesser evil was important to me because I thought I could see how different people process that term in very different ways. Some people think, oh, a lesser evil is just something you'd rather not do, other things being equal, but sometimes you have to do it and it's no big deal, really. Some people think that things that are evil are things that you should not do, no matter what. Right? Other people think that even if you should sometimes do things that are evil, being in a position where you have to choose, or you do choose a lesser evil, has a further grip on you. So it's something very morally serious that you do that has negative implications for how you understand your own life. So those things interested me, and the other thing that interested me is just this general idea that Crutzen was trying to offer a kind of ethical argument for what we should do, morally speaking, given that we're not doing what we should be doing. ethically speaking. And that struck me as an interesting place to be.
Okay, our second panelist is David Keith. David has worked on issues to do with climate change basically at every possible spatial and academic scale, I think, from policy advice to designing satellite instruments. And if the satellites haven't flown and the policies haven't flown, that's not David's fault. Since I'd say about 2000, he's been one of the leaders in the field of thinking about geoengineering. He's a professor at Harvard, and he's actively involved in various geoengineering projects, including one commercial one, but I think tonight talking more on the academic side about solar geoengineering as opposed to geoengineering by sucking up carbon. So David, how did you get into this?
I was a grad student here at MIT in about 1989. I was working on physics. I was building the first interferometer for atoms, and it occurred to me that the work was funded partly by the military that had an interest in very accurate rotation sensors, and the reason they wanted to do that was so they would know where submarines were, and the reason they wanted to do that was so they could know where the missiles would land, and the reason to do that is so you can strike first, because there's no reason to know where they land that precisely if you're striking second. And when I kind of did that chain of logic, I became more disturbed about where that was leading, and I sort of cast around for other things to do, and found a whole bunch of people who were a lot of fun to be with, who worked on climate at both Harvard and MIT, and cross disciplines with no professors except maybe Bill Clark encouraging us. And I just found this topic because somebody else said nobody was working on it and it might be interesting. So that would have been a quarter century ago, roughly. And then I worked on it intermittently for a long time since. I think the reason I've come back to it is, first of all, I'll give you a pragmatic answer. I think it's important. It might actually be useful. Might significantly reduce risks to people now living or to ecosystems that I care about. So that's a kind of pragmatic answer, but that's not the kind of thing that really gets you up every day for a long time. I think the reason that I personally really care about it is I think it encourages us to ask hard questions about the way we manage the planet, the way we think about the natural character of the planet, and a planet we increasingly control. So this may seem very odd to some of you, but I think there's some connection between a question like, should we reintroduce mammoths in the Arctic, make them, de-extinct them? It's technically going to be possible to do that. There are people debating it. I think there are analogies between that question and the question of what should be the long-run aim of climate policy. Are we trying to get back to pre-industrial or to optimize productivity of ecosystems for food production? There's no right answer, but I think these involve some of the same hard questions. And I guess to finish up, I think that the main way this debate on climate has been framed tends to kind of extinguish these questions. So there are things for which economic cost-benefit analysis has been devised, for which I think it's enormously useful. So if you're trying to figure out just how much money you should spend to cut a pollutant like lead in gasoline, and you want to weigh that against the benefit, and it's in one place in roughly one generation, a cost-benefit calculation can tell you an enormous amount useful about what to do. And I think it's a very good first-order guide to what to do. And that's the same kind of machinery we've used for most of the debate about climate change, framing it as a cost-benefit analysis, but I find that important, but not so convincing when one's thinking about a one-time decision for the planet, and there are many generations and values, and I have some waiting for the natural world that's separate just from its utility.
Great. Okay, thanks very much. Our next speaker, our next panelist along the line is Dan Schrag, who is at Harvard and is the director of the Harvard University Center for the Environment, which I think is one of our host institutions this evening. So thanks very much, Dan. I was saying, talking about the spatial scale of David's work. Dan's work has a great temporal scale. It stretches from the Precambrian to the near and possibly even now the distant future. But he looks at climates and how they relate to life throughout the Earth's history. And he also has a strong policy interest and is a member of the President's Council of Advisors for Science and Technology. Dan, how did you get interested in this?
So I'm a climate scientist, as you said. I'm a climate scientist who thinks about climate on different timescales. And I think it's hard not to think about climate and not think about this challenge. Specifically, my involvement in this, and by the way, I really haven't ever published anything about this, so maybe a few sentences in a paper here or there, but nothing really about this. Katie Dagan may change that soon, but I've never really done academic work on this subject. My involvement came from a visit to Calgary in 2007. It was my birthday, January 2007, and I was out having a beer. It was a 70-degree day in January in Calgary. It was a very strange day, and it wasn't climate change, by the way. It was just some very strange weather patterns.
Called a Chinook.
Chinook, the same name as my new dog.
Spooky.
And David was talking to me about this problem of solar climate engineering and his thinking about it. And I was having a beer with him late at night and realized that one of the things we have here in Cambridge, both at MIT and at Harvard, is phenomenal convening power. And so I thought it was an appropriate time to bring a group of scholars, not just scientists, although many climate scientists were there, but also some economists, some lawyers, to sit around and in a group of, it was about 40 or so people, and talk about this issue in a serious way, including many people who'd never thought about it before. And so we did that meeting in that fall, in November of 2007. And for me, that was a very important time to reflect a little bit on this issue and think about it. I see many people who were either there or were in conversations around that time who probably thought about it at that point for the first time. And that was a very important launching point for many of us in terms of thinking about that. That was only 6 years ago, but I think a lot's happened since then. My interest is often thinking about time, and I hope we'll get a chance to come back to this question of temporal scale, because this problem is very much about time scale. The climate challenge, to me, the biggest worry is the time scales, and there's at least half a dozen different time scales that we have to worry about, and that are partly wrapped up in why I think it's important for us to be thinking hard about the solar geoengineering issue. And the only final point I'll make is that I spend my time these days working both on climate issues, but also energy and technology and policy issues. And my general experience, and I can't prove that this is true, this is just my general opinion, is that most of my climate scientist colleagues actually tend to underestimate how difficult it is to change our energy system. And most of my energy policy, energy technology colleagues tend to underestimate the scale of the impact of climate change, in my opinion. And that leads to an interesting resonance that I think is partly destructive. Both of them underestimate the scale of the other side of the problem, these different sectors we're talking about.
Yes.
And I think it leads to a very interesting challenge. And I think the fact is that if we look very honestly at our predicament right now, it's very difficult, and we can talk about that a little bit more in a minute.
Great. And the last of our panelists is Alan Robock, who's a distinguished professor of climatology at Rutgers and former state climatologist of Maryland, I discover by reading your CV. And Maryland's climate has, I'm sure, never been the same since.
I wouldn't know.
Alan's worked in various fields, but is particularly associated with work on the impact of volcanoes on the climate and also the impact of nuclear weapons on the climate. And so he's not unused to quite controversial topics. And Alan, tell us how you got into this.
So as I walked up here today, I saw the Green Building about a block away and reminded me I was a graduate student here more than 40 years ago. And I was looking for in the Department of Meteorology, which doesn't exist anymore. And I was looking for a PhD dissertation topic, and I went to talk to the faculty members, and I went into Ed Lorenz's office, and he said, climate would be a good field to get into these days. It's in 1974, and I was lucky enough to take that advice. So I've been working on this for a long time. After Paul Crutzen paper was published, there was a meeting held at NASA Ames, and I got myself invited to it, and in November 2006, and I sat there for 2 days listening to all these people who are so excited about geoengineering, and I started writing down reasons why it might not be such a good idea, and I published an article, 20 Reasons Why Geoengineering Might Be a Bad Idea. But I thought it was interesting to try and then go through these reasons and to quantify them, and so I've been doing research on it ever since, studying volcanic eruptions at the same time, because that's a very useful analog to this. And I just wanted to explain why I put my hand down for your second question, because I'm one of the people, climate scientists, who thinks it's easier to change the world. The people are worried about tipping points in the climate system, but there's also tipping points in human behavior. It's possible for things to change quite rapidly. We know that there's enough energy from the sun and the wind to power the Earth. The question is, can we get there? Just think in the last decade in the United States, we have a black president and gay marriage. I mean, who would have thought of that 10 years ago? Nobody's smoking in here, so smoking has disappeared. So there are lots of things that change quite rapidly once people understand it. And so it is possible for us to implement mitigation, which we all understand is the actual solution to global warming.
Great. Well, thanks very much, Alan. Actually, I wanted to stay with you for a while, because just to get some of the some of the sort of like basics of the idea shared around the room a little bit. It's often said that one of the things that's attractive, or at least permissive, about the idea of geoengineering by putting a layer of particles into the stratosphere is that we see volcanoes do it, and we understand that process, and we could mimic it a bit. So I wonder if you could just tell us a little bit from your work on how volcanoes do and don't provide a good model for thinking about how humans might go about diminishing the level of sunlight.
Sure. Large volcanic eruptions inject sulfur dioxide gas into the stratosphere, where they react to form a cloud of sulfuric acid droplets and stay for a couple years and reflect sunlight and cool the planet. We know that from observations, and so that's served as the model for humans doing the same thing. The big difference is that volcanoes put a cloud up there once, and then it goes away. For us to maintain it, would have to continuously inject material up there to keep the cloud up there. But we can learn a lot from observing volcanic eruptions, both about the benefits and the risks of geoengineering. We learn that if you put a cloud up there, it will reflect sunlight and cool the Earth and reduce all the other things associated with that, like sea level rise and ice melting and things like that. But it also teaches us that there are many risks. One of them is that there will be changes in the monsoon circulation and the atmospheric circulation, so you wouldn't get uniform cooling and uniform changes of precipitation everywhere. They teach us that if you keep the temperature constant, that you'll reduce global precipitation. They teach us that these aerosol particles would destroy ozone and put more ultraviolet radiation down to the surface. They teach us that there'd be more diffuse radiation rather than direct radiation, and that would have an impact on plants. It would actually increase the carbon sink, but it would also rearrange the natural and engineered ecosystems in ways that we really don't understand well. So there are both good and bad things we can learn about this topic from looking at volcanic eruptions.
David, how do you feel about that list of good and bad?
Pretty much complete agreement. I mean, I think the only place where not really disagreement, but another thing to say is maybe twofold. One is that in terms of it's certainly true that if you increase the temperature of the Earth by adding CO2, you can bring the global temperature back down to the pre-industrial if you wanted by reducing the sunlight. That's simple, two curves across. It's for sure true you don't get back to the same climate. For all sorts of reasons. They're just different, what we call climate forcings, the way you push the climate by adding CO2 and the way you push it by changing the sunlight, even if you could do that with a magic knob as opposed to some putting crap in the stratosphere, is different. But it's not, there's limits to how much you can learn from a volcanic eruption in terms of the atmospheric response, because for reasons that we understand really well, but are very easy to explain, to do with the fact that the ocean holds heat much better than the land, a sudden volcanic pulse that cools things down changes atmospheric circulations in a way that's quite different from a long, slow cooling. Not to say the long, slow cooling would be perfect, but the analogy there is pretty distinctly imperfect.
Dan, is this an opportunity for you to say a little bit more about timescale? I mean, we're talking about things that happen over years here, but your interest is, I think, more on the sort of like centennial timescale and beyond, yes?
Actually, I'm interested in many different timescales, and I think what's so interesting about this problem is you have to think about different processes that are occurring on so many different timescales. I want to caution, first of all, right away, and David sort of hinted at this, but it's very important when we think about the impacts of doing some sort of stratospheric reflection of sunlight to balance the radiative forcing from greenhouse gases. It's very important that we remember we have to compare a geoengineered atmosphere with a future atmosphere in which you've allowed greenhouse gases to go up and not geoengineered it. Because one of the fundamental timescale questions is the timescale of the carbon cycle, and that's very long. So something like 20% of the CO2 we put in the air from burning fossil fuel will be there 10,000 years from now, and will be there for a very long time. So that's a very long time scale. But there's also a lot of inertia in the energy system of the world, so that the best possible scenario of fossil fuel reduction, which is frankly unimaginable, still adds another 500 gigatons of CO2, still ends up at 600-ish parts per million of CO2 in the atmosphere. We're almost at 400 parts per million now. So basically, there's this timescale of the energy systems of the world and the turnover that gives us that timescale that's very difficult to avoid. There's also something frustrating about if you look at what if we took a lot of action to reduce emissions, how would it actually affect our experience of the climate? This is one of the things that makes this problem so politically difficult. The truth is that if we actually reduce emissions a lot, say the US and China, by the way, some people don't realize this, it's about 6 years ago, China passed the US as the largest emitter of CO2. In 2011, their emissions were 53% greater than the US. That's just in 6 years, 5 years actually. It's astounding how fast that has happened. That's partly because we've shrunk a little bit and they've grown a lot. But the important point is that the CO2, it's going to be there for a very long time. And even if we took dramatic steps to reduce emissions, it's not going to affect our experience of climate in the next 30 or 40 years. It will affect a little bit our experience of climate sort of 30 to 60 years out, and substantially affect our climate experience 60 to 100 years and beyond. But think about that. You're asking people to do substantial changes in their lifestyles, perhaps with large costs. Certainly today the costs are substantial, for benefits that do not accrue essentially in our lifetime. This is mostly, not even for our children, it's really for our great-grandchildren and beyond.
Maybe for their children.
Maybe for their grandchildren, okay? My great-grandchildren, your grandchildren. Still, that's kind of hard, right? I mean, that's a difficult thing to sell people. It's not surprising why people might be a little hesitant to buy into that. Now, I believe that it's urgent that we do that, but you can understand why it's actually a difficult case to make, because the timescales are profound. And there's this inertia in the system. We've already committed to warming for the next at least 50 years and possibly way beyond that, because there's also a timescale of the climate response as well. We don't exactly know what it is, but it's quite possible that because of the ocean heat uptake, that actually the Earth will continue to warm, the ice will continue to melt for centuries, even if we stopped emitting CO2 tomorrow. So, there is a serious challenge here that comes from these different timescales that tend to be very long. Now, some people, like Ray Pierre Humbert, have argued that the very long timescale of carbon in the atmosphere means that if you start geoengineering the climate, you have to do it forever, and therefore you shouldn't do it. And that's an interesting argument. I'm not sure it's quite correct, because you can also start taking CO2 out of the air and reverse the fossil fuel burning over long timescales. It does mean that you should be very wary of it. You should be very cautious because once you do start, you are kind of committed to doing it for at least centuries, if not millennia. But at the same time, that doesn't mean you shouldn't do it. And it really depends on what the alternative is and how bad climate is. And it depends on what you care about. Do you care about human impacts? Do you care about poor people in certain parts of the world that are vulnerable, most vulnerable? Do you care about natural ecosystems that are going to be decimated by climate change? And different people have very different answers to that. If you really cared about natural ecosystems, I actually think that's ironically the strongest case for immediate geoengineering is if you really care about natural ecosystems.
Now, interestingly, the strongest moves to actually have a moratorium on geoengineering have come from the discussions of the Convention on Biological Diversity. But Stephen, I wondered if I could bring you in. I was struck when Dan said that the proper thing to compare a geoengineered world with is a world with unabated CO2. And I wondered, is that, from your point of view, the proper comparison, or does that sit well with you? My reading of your work suggests possibly not.
Well, a lot of what Dan said fits incredibly well with what I think, because one of the main problems that I think we face, one of the main challenges, is the ethical challenge, as I see it, of a major intergenerational problem. Dan said, well, if the current generation isn't going to experience any real positive changes from serious action over the next 30, 40 years, and then some modest benefits after that, what's the real reason? It's a hard sell, was the thought. Well, it's a hard sell if one is assuming that the dominant motivations we have will either be self-interested in some narrow classical sense, or else just generation relative. Maybe we care a lot about other people, but only other people in our own generation, say. Then this becomes a really hard problem. And I've written quite a lot about why I think this problem is much harder than the traditional problem it's always talked about in environmental affairs, the tragedy of the commons. Right? Tragedy of the commons looks really nice compared to this intergenerational problem. Looks like a really easy problem, and we know that it isn't. But it's true that I do, in other parts of my work, for a connected reason, have trouble with always making the relevant comparison case with what happens if we just, do what we want for narrow, self-interested, or generation relative reasons. But I don't think actually that Dan and I disagree about anything here. But I think there's a real risk that a part of our public discussion about the climate problem rests on this kind of framing. Well, the way to get climate action is to try and persuade people in the current generation that it will be good for them to do it, right? So we take our benchmark to compare everything to what happens under some kind of business as usual scenario, right? And then we try to persuade the current generation that it will be doing better than that scenario under a scenario where we do something about climate change. It strikes me as it would be a good thing if, from a certain point of view, if the current generation could do even better than under its current trajectory out of doing something about climate change. But there's something backwards about, and in fact, worse than backwards, something morally deeply problematic about issuing that as the demand, right? I think we have a really strong ethical reason, personally, to do something about this problem, then, or at least one. One of them is our concern for future generations, which is an ethical concern. And given that ethical concern, I don't think the benchmark should be how well we can do by exploiting the future as much as possible. So I think one practical consequence of this is that we shouldn't get too caught up in all the rhetoric and argument about whether we can have a green energy revolution that maximally benefits the current generation and makes them much better off than they would be under any alternative. I think we've got to act on climate change, even if that's not true, even if the current generation maybe does worse in certain ways under doing something about climate change. Why? Because ethically we should do that. We need to protect future generations against our activities.
I wonder if I could stay with you briefly to look particularly at the geoengineering aspect of this, because I think there's a very interesting point you make about finding reasons for inaction. That's in fact one of the strengths of that Jane Austen chapter I was praising. But you write elsewhere in the book that pursuing geoengineering programs as lesser evils need not manifest moral corruption, but there is a high risk that it will. I wonder if you could say a little bit more about that moral corruption, which you see as possibly existing even if there are good arguments for geoengineering. What's corrupt about this undertaking?
Right. So one of the things I've been interested in is how we frame the geoengineering question. Right, and particularly what difference it makes if, as I see it, we're in a perfect moral storm situation where we face these strong temptations, in particular, to pass the buck on to the future. For example, to take what might be modest benefits now to us, even though the cost of that is to impose large, perhaps catastrophic costs on the future. One thing you might worry about is if we face a strong temptation to do that, then given that the future generations are not around to press their own case, we might shift in that direction but not want to admit to ourselves publicly that that's what we're doing. And in particular, there will be less pressure than there should be on bad ways of framing the debate that we're in. So in geoengineering specifically, I think there's far too little discussion of possibly forms of geoengineering that would amount to passing the buck to future generations. So forms of geoengineering, for example, that I would call parochial. We'd be very interested, if we're a buck-passing generation, in a form of geoengineering which would have short-term benefits over the next 30 to 50 years, and not very interested in if it has really bad consequences after that. Perhaps worse consequences for future generations, even than carrying on with the climate change. And one where I think this kind of worry, the live threat of parochial geoengineering, seems serious to me, is that a lot of the framing in the, admittedly very early literature of geoengineering makes two kinds of arguments. One is we just have to do geoengineering research and then probably to deploy because this is an emergency and the normal constraints don't apply. Right? So it discourages thinking about the profile, if you like, of the costs and benefits of geoengineering. But also, a large proportion of the early literature keeps talking about geoengineering as if it's what's called in the technical literature a global public good, which means, among other things, for most people, that it benefits absolutely everybody. Right? Well, I think that's a little too fast and too complacent. I mean, we can't just assume that some kind of geoengineering intervention, shooting stuff in the stratosphere, is magically going to benefit everybody, especially when we're talking globally and across multiple generations. Right? There's nothing magical about shooting stuff in the stratosphere that guarantees that. In fact, I would argue even that it's probably too strong a requirement because it makes geoengineering probably will never satisfy that requirement. It's too strong. Think about it. Benefiting absolutely everyone globally and across all generations. It's a bit of an absurd idea, I think, for a technological invention. It's too high a bar to meet. So why does it persist? Well, arguably, it persists because we're just not thinking hard enough about these questions about the intergenerational profile of geoengineering. Sorry, I went on too long.
David, I saw that you wanted to come back, I think, after Dan, but you may well want to come back on that two, and then I should just tell the audience two things. One is, any of you standing at the back, there are a few seats at the front if you feel like taking the walk of the reverse of shame into the public eye. The walk of fame, yes, thank you. Also, after David's talked, I think I'm going to start opening up to questions from the audience, so please have questions in the audience. I'm not quite sure, is it the mic down there we're going to be doing, or is it a roving mic?
Just here.
Okay, so you will too will have to take the walk of fame, but first of all, we'll hear from David.
Yeah, I think what I was picking up was right in between the two, so it's perfect. I think a very common intuitive reaction and healthy reaction is that this idea is nuts and we should just get on with cutting emissions. And that connects a little bit to some of the stuff that Steve has written about the kind of limitations of lesser of two evils arguments. Those arguments are only hermetic if there really are only two choices and a one-time choice, and that's not usually the case. But I think the key distinction here is that to a good approximation, not quite, the following physical facts are true. We can then go to their moral implications. Things you do with this solar geoengineering might reduce risks for many. They will certainly increase risk for some over the next, say, generation, few decades, 50 years. And they do absolutely nothing for the long-term future, one way or the other, to a good approximation. And cutting emissions, to a good approximation, does nothing for the next generation and is the only thing that in the long run manages the kind of long run risk we pass to the distant future. So there are quibbles with that, but to a simplistic approximation, that's the deal. And what that means is these two things really, at some level, deal with different things. And the problems come to the extent that we, in our decisions, couple them too much. So if we, as a result of making decisions that, let's say, to implement solar geoengineering, reduce risk now, if we end up reducing, doing less to cut emissions, so emitting more than we otherwise would have, then we are morally responsible for passing on this added risk to future generations. And I think that understanding that it's not a trade-off at a single time, but it's a trade-off in two times is crucial to making sense of this problem. Not that that tells you that there's a simple answer, but it's a fundamental piece that people often confuse.
Sure.
I agree with what David said, but I'd like to frame it a little bit differently. Geoengineering may reduce some risks associated with global warming, but it may produce others. And so we really have to compare the risks of doing it with the risks of not doing it. And we really can't answer that question yet because we have to do the research to really quantify each of these risks. And that's what some of us are doing. And so another thing volcanic eruptions teach us is that once the aerosols go away, the climate warms rapidly. What if we were doing geoengineering and there was a terrible Indian monsoon for a couple years, and people said, "Oh, it's because of those geoengineers. We have to stop it." And there's society loses the will to do it, and we stop. You'd get much more rapid climate change than you would get if you did nothing, and you were adapting to the slow climate change. So those are some of the issues we still have to consider in some future decision whether or not to do this.
But Alan, do you think that you can, how much of the risk do you really think you can retire with the sort of research you're talking about? I mean, it seems to me that you can deal with maybe most of the known unknowns, but it's not clear to me that you can, that the idea that you can retire all the risks before making decisions about geoengineering seems to me not obvious.
No, I agree. So I've written a paper, will geoengineering ever be used? And my opinion was no, because of these governance issues, because of the unknown unknowns. Donald Rumsfeld was right about one thing. We don't know what we don't know. Because we're going to put the entire fate of the only planet that we know that can sustain life on this one technical intervention, which may go wrong. So there may be different I mean, what if we could do it? Whose hand's on the thermostat? How do we set, for you young people, that's how we used to set thermostats. How do we decide how much geoengineering to do? What kind of governance would we have to do that?
Dan.
So let me interject here, because I think there's something important here. I agree with all those questions, and people who've heard me talk about this subject know. I think the governance question, who controls it. By the way, I really do think it's important to discuss the ethical issues and think about them and frame them. But my sense of the way the world actually works is that they actually don't care about these issues too much. Unfortunately, we all agree that poverty is probably, extreme poverty is ethically wrong, and yet there's a lot of poor people in the world. And unfortunately, that persists. Unfortunately, we don't make decisions that way, and so I want to solve this problem. As far as what you just said, I think you're right. These governance questions are huge, but I think you're understating what we're doing by burning fossil fuels and putting CO2 in the atmosphere and letting the climate run amok. You're making it sound like there's this horrible experiment that we're going to do with geoengineering, and forgetting the horrible experiment that we're doing by putting CO2 in the air. And by the way, I want to point something else. I actually do think...
That's not what I said.
I agree with you also, though, that I do agree with you that the stratospheric questions, the stratospheric chemistry ones, are probably the most important, partly because they're the ones that are the sort of most dangerous failures of a geoengineering system. I think it's important to remember that for the last 60 or 70 years, we've been putting a lot more sulfur into the troposphere, and based on IPCC estimates, reflecting anywhere from half a watt per meter squared to almost 2.5 watts per meter squared of sunlight because of tropospheric sulfur that only lasts for a few days to maybe a week or two, but we put so much of it in from burning coal and burning high sulfur liquid fuels that we've been doing this experiment for 70 years. Now it's troposphere, not stratosphere, but let's remember that the net warming that we've experienced is a combination of greenhouse warming minus the reflection of sunlight from sulfate aerosols. We've been doing this for 70 years. So it isn't intentional. We haven't done it intentionally, and there's a very big difference, but still, the actual experience of climate that we've all had for our entire lifetimes has been in a world that has seen a balance between increased greenhouse warming minus increased reflection of sunlight at the same scale of what we're talking about doing in the future.
And with enormous side effects. So Alan, kind of responding to me, said, well, he's thinking about the risks, implying that I weren't. So, for instance, Steve Barrett and I and others in this room are working to quantify how many people would die by particulate air pollution if we put sulfate in the stratosphere, to do careful quantification of wherever Seb is sitting. But to put that in context, that amount of sulfur we put in the lower atmosphere now kills about 1 million people a year. And so we're dealing with big risks on both sides. And I most certainly don't think that let me try this a different way. We absolutely have to quantify the risk. But a thing you often get in climate policy, geoengineering and other parts of it is all the same, is people from the academic world who kind of naively assume you need to know all the answers in order to make a decision. That's just not the way the world works. In the real world, in the political world, politicians routinely make decisions under high uncertainty. Do they do a very good job of it? I'm not that satisfied. But the reality is that they get made. That's the political sausage machinery. And the reality is we make a decision by doing it or by not doing it every day. There's no avoiding the decision we're doing. If we decide to study geoengineering for 20 years and not do it, that's a decision. If we do it right away at full force, that's a decision. I would say a very bad one. But there's no getting to certainty here. And there's no avoiding the fact we're making decisions with big consequences and big uncertainties on both sides. And I think it's worth saying that from the understanding of the climate models, the same climate models that tell us about the climate risk, if we put in quite moderate amounts of geoengineering that we understand, the evidence to date from those models suggests, from what we know now, that they would significantly reduce risks, if used correctly. One last point. If you asked me to vote right now about whether we should do this at scale or abandon it forever, hard vote. I might even choose abandon it forever. Right now, we've got a small clique of people, of whom I'm one, and Alan too, who've done a lot of the research, and there's a real danger of groupthink. And before I personally would be comfortable with this kind of going out in the real world at a larger scale, we need to broaden that group dramatically. Have many more people come in, have a much wider debate in the scientific community and beyond. But that doesn't have to take decades.
Stephen, I just want to come back to Stephen, because I thought there was a way in which, in a very nice way, Dan raised the question of whether we should actually care about the ethics of this or not, and I wondered if you could just maybe come.
Not quite fair.
It's not the least fair thing that's been said on the panel so far either.
And,
so,
Stephen, just before you start, if anyone has a question, can you make yourselves known to me or walk up here and I'll come and get the microphone?
yeah, I will pick people out. I'll pick people out. So, Stephen, if you could come back in, but I'm going to pick people out from now on, okay?
Randomly?
No, I'm going to choose people that I want to choose. I'm not going to do it damn randomly. I'm going to go with that guy first. The man's... Yeah, but I'm going to start with Steve first, yes. But you will be... no, I'm going to go with Steve first, and then I'm going to come to you.
Oh, okay.
Yeah.
Yeah, I think, Dan expressed some sympathy with the ethical view, but then went on to express the worry, which I think is widespread, that maybe ethics never really changes anything, and so we need to do something. In fact, I remember Dan saying, I want to solve this problem, which is an attitude I hear a lot. I think what worries me a bit about that claim, I want to solve this problem, is I'm really interested in what the problem is. If you don't care about future generations, you don't care about non-human species, you don't care about the world's poor, then it's not very clear to me that there is a problem, right? Because of the big time lags and so on. And more importantly, perhaps, it's not clear to me what problem you will be solving if you address the problem in that constrained way. So in the book, I talk about shadow solutions, right? And I, in fact, given an analysis of what happened, or what's happened in international climate policy, which suggests we might have been pursuing shadow solutions. The global political community has a small interest in climate change insofar as it affects powerful actors in the current generation. And that gives you a reasonable explanation of why we've got the kind of global climate policy that we've had, including the perpetual promise that we'll do it in another couple of years. There'll be a big meeting, right? And then it doesn't actually happen.
Well, the meeting does.
Yeah.
People have their hotel rooms in Paris booked, man.
But it's all something. So again, it links to moral corruption about this continually wanting to give the appearance of being serious about solving this, but not actually doing anything. And this worries me specifically about the geoengineering case, actually. Because if you're in a circumstance of political inertia, then you might think, suppose there are good geoengineering options, and Alan's given us reasons to worry about that with sulfate injection, but never mind. Suppose there are some pretty good options. One might worry, are they really on the table? I mean, here's something I would think about the social side. Given that I don't think we're going to get geoengineering that magically benefits everyone forever, I think we're probably going to have some compensation regime, whereby those who are benefited by the geoengineering help to offset the cost to those who suffer from the geoengineering. Think about a global international compensation regime. Is that really feasible under current circumstances? Or does it run into the same kinds of problems that mean people are not very interested in mitigation and justice issues of mitigation? Maybe it does. What about procedurally? If you're going to have a good geoengineering policy, then as Alan already mentioned, there are major questions of global legitimacy and justice involved in making decisions about that kind of intervention. Is that very likely under current circumstances? Well, the experience with mitigation and so on might suggest that it faces some real hurdles. So we might find that the best the ethically defensible versions of some imaginary geoengineering scheme, physical scheme and the social side of it, are not actually all that available. And so that the kinds of geoengineering really on the table are ones that I worry about, like the parochial ones and the predatory ones, where some nations pick a kind of geoengineering that works very nicely for them, but not very nicely for their major competitors, and so on. And these are things that I think we do need to worry about when we're thinking about shadow solutions and the problem we're trying to solve.
Okay, we'll go to the audience now. If you could say who you are, and make the question reasonably direct and quick. I'm not sure I'm necessarily going to take all questions as they come in. I may group some together. I'll probably also respond to the looks of enthusiasm or terror on the faces of the panel. But how I will respond, I will reserve the right. So, sir.
So, Fred Hapgood, a simple person would think, well, the obvious solution is that they put the carbon dioxide in. Why don't we just take it out? That would avoid all of these problems. Could somebody analyze? Obviously, nobody's mentioned that. There must be really, really good reasons why this whole approach the door's been closed to it. What are those good reasons? Okay,
I'm going to bank that and move on to the gentleman in the rather fine paisley shirt there. So that's, the microphone is coming from behind you, sir.
Okay. My name's Chris. I'm a nurse, and I have some concerns about geoengineering. Stephen, I'm kind of in line with you on your theories. I believe that there's deeper issues here when you look at like the stratospheric Welsbach patent already in existence, and you look at Raytheon's patent 5003186 for the aluminium, and you get the Monsanto connection with their aluminum-resistant seed. And it's not just sulfur, I think, we're talking about here. I think it gets into a much deeper ethical debate. And I'm concerned about, just from a medical standpoint, if we do we know Bill Gates has invested heavily into his sulfur geoengineering and his 500,000 stocks of Monsanto. So I'm worried about the aluminum and neuroprogressive diseases in the future if this is more than sulfur. I personally like the volcanoes because I'm an enthusiastic person of zeolite powder as far as heavy metal detox. So I'm concerned about geoengineering in general, and I don't think we should do it.
Okay, and the gentleman next to you,
I'd like to make, I'm Clark Apt. I'd like to make 2 points. In somewhere between 100 and 200 years at current rates of consumption, the carbon fuels, including coal, will be exhausted. And we will be forced to rely on renewables and some advanced nuclear, if you can consider that a quasi-renewable. So the cutting emissions, carbon emissions, is going to happen anyway. Whether it happens in time to save us from disastrous climate change, there is a way that some nations may unilaterally insure against it. At the Helsinki meeting of the International Physicians for the Prevention of Nuclear War about 6 years ago, 2 climate scientists presented a paper showing that even a so-called small nuclear war.
I was one of them.
Okay, I think we'll keep that one up. But Clark, you asked a question about running out of fossil fuels. So if you want to come to another point quickly.
Yes.
Nikola Tesla.
The point is that a nuclear power could generate a lot of global cooling, not maybe nuclear winter, but nuclear autumn. And the problem is, how do you avoid the nuclear winter, which would cost billions of lives through starvation, and still, how many of those bursts of geoengineering are enough? And
okay, thanks very much. I'm going to ask Dan to come back on the question both of why we don't suck more carbon out of the atmosphere and also the question of running out of fossil fuels. And then I'd also like maybe David to take on Chris's points about aluminium and the industrial complex.
So in terms of sucking CO2 out of the air, David
Leave it off
has thought a lot more about this than I have, but I would say that it's very much on the table. It's not off the table. It's just very expensive. But it's very much on the table, and there's some people even at this table who are thinking commercially about how to make it work at a reasonable cost, and it remains to be seen whether it will be at a reasonable cost. There are all sorts of different ideas, including, by the way, making biofuels and sequestering some of the CO2 in that process. And it's a question of cost and scale, but the time scale is inherently long, because even getting to, we're putting in, right now, we're burning roughly enough fossil fuels to put about 10 billion tons of carbon, not CO2, but carbon, so 36 billion tons of CO2 into the air every year. And getting to 1 billion ton of carbon would be a remarkable feat if we could suck up that much. So I think it's, in the long run, sucking CO2 out of the air is going to be essential. I just don't, we have this transient problem, which is the next 100 to 200 years. Now, as far as the question of fossil fuels and running out, don't be fooled into thinking that we're going to run out of fossil fuel anytime soon. Remember, coal reserves is an economic concept at current prices. If prices go up, there's a lot more coal out there. And if you actually think about all the fossil carbon that could be exploited for energy, it's a very big number. People have various estimates, but it's something between 2 to 5,000 billion tons of carbon. We've put in about 500 so far. We're going to put in another 500 even if we dramatically reduce emissions. So the question is, how much of that 2 to 5,000 extra are we going to put in the air? Okay. That's the question. And it's nice to think that, well, we'll run out and prices will get so high that alternatives will come in. I unfortunately wouldn't bet on that. And I think, for example, the shale gas revolution in this country is an example where innovation in fossil fuel extraction has outpaced innovation in renewables so far.
David.
So I think, just guessing, because I've had lots of interaction with folks, that you're probably talking about what is called the chemtrails conspiracy.
Well, solar obscuration. It's not.
So I'm happy to let you talk if you want.
No,
Feel free.
Chemtrails is like not a very good term. It's solar radiation management, solar obscuration, those types of things.
So I'm just doing my best to answer as I know, and I'm happy to have you talk as much as you like. But if you want to hear what I have to say, then
absolutely, that's why I'm here.
As I understand it, and I've invited people who believe in this into my office to talk about it, and you can look for the videos. I've also had 2 death threats from such people, many actually, more than 2, but 2 serious enough that we called the police. People appear to believe a wide range of things, but broadly that elements of the U.S. government are spraying toxic chemicals, sometimes claimed to be barium or aluminum or various other chemicals sometimes claimed to be from commercial aircraft. And then the hypothesized reasons for this are mass culling of the human population or mind control. There's a variety of them. This is not a completely obscure view. So my student Ashley Mercer and I ran a survey, a high-quality survey with polling firms of U.S. audiences and U.K. and Canadian. And we asked a question that didn't use the word, because I don't know what word to use, but we said, is there a conspiracy by the U.S. government, blah, blah. And we got about 2%. Ashley can correct me if that number's wrong. So that's not an obscure number. It's a significant. So you represent a real group of people. So from my point of view, to be blunt, this is a completely baseless conspiracy theory. I have no reason to, and I've seen no evidence, despite actually taking my own time to look look for it, that there's any there. So
Even the 2001 Space Preservation Act,
I have
2977.
no idea what that is, but again,
Stem cells is specifically listed in there as an exotic weapon.
sure. So I actually,
It does exist.
fair enough. So again, you're free to talk, but if you want
Well, I'm
me
just
to,
saying it does. HR 2977.
well then, it sounds like you know the answer, but I could give another few words about what I've done, and then we could wrap it up. I'm happy to talk afterwards.
Sure.
So the things that I've mostly interacted with is people presented me what appeared to be data to show that aluminum was coming from the sky. And this data had no controls and didn't seem to take account of the fact that aluminum oxide is one of the most common elements of the Earth's crust. And the actual data that I saw didn't look any different from normal chemical analysis you see all the time. And I asked these people responsible questions about that and got no answers that made sense to me. Just hold on a second. And the other main thing that people say is that contrails in the atmosphere didn't used to look like they do now. And so people, I get literally, I'm not making this up, probably one email a day on average, maybe two, telling me that I'm messing with the climate personally and that these contrails look different than they used to. And one of the odd things is, like, there's no evidence. People are completely sure this is true based on just contrails looking different. And one thing they say is that they'd never looked like that before. And there are actually some good websites debunking this conspiracy theory that have a bunch of photos of contrails in the 1960s that look just like they look now, because it's the same processes. And so, enough said. Bottom line is, I and several other people here, including Alan, have talked with folks maybe like yourself, and I'm happy to talk, but I have no evidence whatsoever there is such a conspiracy. And since I have kids too, I would be highly motivated if I thought there was such a conspiracy to do my best, including risking my life, to expose it and show it for what it was. But I don't think there is any such.
Okay, I'm going to take some questions from towards the back. I've seen various people towards the front, but since partly because I recognize them and partly because I'm nearsighted, I'm going to assume that I have some bias there. I'm going for the guy in the green check shirt.
Kyle Armour, I'm a postdoc here in EAPS. My question is, I want to bring it back to solar radiation management. I think the argument can be made that it's most useful at the times that it's perhaps most dangerous. For instance, if climate sensitivity is slightly higher than we think it is, if we continue emitting at a high rate, or if there are climate emergencies that are unpredicted. And these are precisely the times we maybe want to use solar radiation management, but they're the times when we shouldn't for risks of shut off abruptly warming with high climate sensitivity, or perhaps with climate emergencies, we just don't understand the climate system as well as we thought we did. So I was wondering if you guys agree with this viewpoint and also how it would affect your thinking about whether we should do it.
Great. Any other questions in that general vicinity? Okay, I don't think that really counts as the general vicinity. But do you have a loud voice?
Yes.
Okay, tell us who you are, and we'll get the microphone over to you in some way or other.
Alan Nadikov. What is the geoengineering for creating a semi-permeable, a transparent net that absorbs sunlight and creates electricity that could be transported in the circuit field?
Okay. Any other questions from around there? Yes, you. Yes, you even got a microphone.
How do you think about the moral hazard of geoengineering? I would imagine people would be less inclined to decrease carbon emissions. And I was also wondering if you could talk about the health impact of aerosols in the atmosphere. I thought that was a health hazard, but I'm not really sure.
And I'm going to take one more from Mike, who's sitting just in front of you.
Hi, Mike Fowler. My question for the panel is, given the controversy, some of which is apparent in the room, and you touched on, at least somebody touched on, sort of the research questions, and I'm wondering, the research agenda, if you will, for this particular kind of geoengineering, is it hard to flesh that out in the sort of current political climate? And if it is, why, or how can we get around that? And if it isn't, has such an agenda already been fleshed out in terms of, especially the upper tropospheric and lower stratospheric chemistry? Do we understand the questions? Do we have a plan in place to how we would go about answering some of those technical questions?
Thanks very much. I'm going to bring those back to the panel. Is there anything else you can do in the stratosphere other than just block out sunlight, or is this really the only thing that the stratosphere is any good for, David?
I think picking up on your comments this morning, I would love to travel up there so I could observe the curve of the Earth and see its beauty.
Okay, but tourism and solar radiation management and more, you don't think there's any...
The flip answer. I mean, the stratosphere serves all sorts of functions, principally one very important one being the ozone layer that allows life to exist outside the oceans.
And the question, sorry, Alan, do you want to?
I just wanted to answer a couple of questions.
Okay, come on in.
Okay, so there was a question about the health hazard of sulfur, and David mentioned it before too. Proposals for geoengineering think about putting 5 or 10 billion tons of sulfur per year, gigatons, teragrams of sulfur. Is that right? Five teragrams?
I think one of the issues here is kind of vague proposals. So I have tried to lay out specific proposals, and they don't do that.
So we've done experiments putting in 5 teragrams of SO2 into the atmosphere every year to block out sunlight. It turns out that volcanic eruptions every year in the troposphere put out about 13 teragrams of sulfur, of SO2, and humans put about 100 teragrams of SO2 into the atmosphere through pollution. And places that are really badly polluted, like in China now, suffer from that. And the health aspects of that are really bad. But another 5 from geoengineering wouldn't make much difference on a global basis. So that was one of my original reasons that it might be a bad idea, too much more acid rain. But I've crossed that off because it doesn't seem to be, that's not really one of the concerns about geoengineering.
Can I leap in? This is a really important moral point. So if I made a decision, or if there was a collective decision to do a geoengineering program, and you put, say, the kind of program I think makes more sense to put about 1 million tons a year in, but let's say, you might end up killing many tens of thousands of people a year as a direct result of that decision. I think that has moral consequences. I don't sweep it under the rug. So this is a case where I take this much differently from Alan and think it's a much more serious issue. Now, it's true that as part of doing that, you would hope that the overall benefits of human mortality would be so that you would save many, many more people than that. But the fact that you would save more people than you kill doesn't mean there's no moral impact of making a decision that directly kills people. And I think that we who talk about this have a duty to be clear-eyed about the direct risks involved in doing it.
I actually think one of the most important questions we heard from was the question about acute triggers, and sort of. I think we've seen this in this country with Sandy, where climate change for at least a little while came back on the political radar screen because of extreme weather, whether it was actually caused or affected by climate change or not. And I think it's a really interesting question about, and I agree that actually that's the most likely scenario to me, that some country or a group of countries is going to decide to actually do this, or at least move towards doing it on a fairly accelerated schedule, because suddenly some extreme weather happens, some heat wave, some drought, and people freak out, and there's a panic and an emergency. And by the way, I wish ethical considerations were important in those situations, but politically they tend not to be in those sort of dire situations. I wish they were more important. But I think the important thing is that if you actually look at how geoengineering, solar radiation management intersects with the climate problem, I worry that actually it's not terribly effective at some of those very, extreme variability issues. And to me, the case for solar radiation management is more about some of the slower, longer-term threats that are persistent, the decay of the ice sheets, rise in sea level, things that, now there's a question about whether whether you can actually change them much with solar radiation management, but I think there's a mismatch of timescales here, where it's likely to be that the decision to do this or accelerate its deployment or thinking about its deployment is going to come from some acute event, and yet the best rationale in my mind for why you might want to do it comes from some of the longer or intermediate timescale things, not the short timescale ones. So I think there's a little bit of a tension there.
Yeah.
I just wanted to answer a couple of the other questions. One was about the research agenda. In the UK, in England, and in Germany, and in Europe, there are multi-million euro, multi-million pound research programs in solar radiation management and geoengineering, and people compete for these. There's no such thing in the United States. However, it is possible to get research grants to study geoengineering through the normal process of applying. I'm supported by the National Science Foundation through research grants to study geoengineering and also study volcanoes as an analog. And so I know people that have NASA grants to study geoengineering. So even though there's not a nationally organized program, it's an intimate part of climate research. We've organized all the climate models in the world to do the same experiments so we can see what the effects are. It's this GeoMIP project. We just submitted 12 papers to a special issue of the Journal of Geophysical Research about that. People volunteered their time to do it, so all that money that paid for these runs comes out of research programs that already exist because it's an interesting question and it's the same models that they've used to study global warming. So there's no problem with doing the research. People that are curious about it do it. There's just that there hasn't been an organized research program in the United States yet. I think there should be, but there should be funding for it, but I'm not sure it should be separate from the research that's going on anyway.
Dan, what do you think about that? Across countries is really interesting. You mentioned
CAA just come out with their thinking about investing $680 million into weather modification. This was actually a
No. The CIA, there's a National Academy of Sciences panel which was asked to write a report to the nation about assessing the geoengineering research. And the CIA is one of the organizations that's funding this open, transparent report that's going to study and report about what we know about geoengineering. They're not going to do any new research. They're just going to take what we know and assess it.
But remember, attitudes across countries are very different. You mentioned Jane Austen earlier. Did anybody read the article in the New York Times about the big debate in the UK about putting Jane Austen on the 10-pound note? Very interesting, because that would be unimaginable here. And in fact,
what you mean you wouldn't put Jane Austen on a back?
And in fact, well, no. What was interesting is the big debate was the motivation for this is that there's been a decline in the number of women on the currency in the UK, and this was a big concern. I don't know that anybody's even raised the question in the U.S. of why there are not enough women. The only woman I know on the currency is Sacagawea. Yeah. But here's the interesting question.
Susan B. Anthony.
Susan B. Anthony used to be, right, but it's no longer being printed. So here's the interesting thing. People completely missed who Jane Austen would be replacing on the 10-pound note. Charles Darwin. Now try to get Charles Darwin on the currency in this country. So let's just remind people that attitudes are really different across countries.
But going back, going back, Dan, how would you like to see Mike's question about how do you flesh out this interest into a research program? Do you think there's a need for that?
I think that there has been, frankly, partly because of the moral hazard question that concerned a lot of people. People were afraid that by talking about this and by doing research on this subject, that we would somehow make people think that we could just keep burning fossil fuels and take the pressure off. I think gradually people are realizing we need to do this research regardless of that, because it really, whatever effect the research would have on our reduction of fossil fuels, the risks of climate change appear to be far worse. So I think that attitude is gradually changing, but there's no question for a while there was a taboo. It was definitely difficult. If you put a proposal in to do work on geoengineering, there were some reviewers who just said this shouldn't be funded, period. And that's hard. I think that's gradually changing. I think it's very different now than it was 5 years ago. I think it still has a ways to go in this country, and it's not at the level that Alan said, where in other countries there's actually a coherent program. It's not there yet.
I'm going to move in and get some more questions in.
One thing about the moral hazard. It turns out that there's also a negative moral hazard. When you ask people about geoengineering, and they say, "You're going to do that? You're going to do that to save the climate?" Maybe it really is a problem. Maybe global warming really is a problem. So it can work in both ways. If you tell people we're thinking about geoengineering, may make people even more worried about global warming than if you don't.
Stephen, how do you feel about that, using geoengineering as the stick rather than the bait?
Well, first thing I want to say is there's a paper by Ben Hale that actually points out that there are, at least 20 different uses of the phrase moral hazard at stake in this debate. So it's a little bit tricky to know what the moral hazard argument is, although there is this sort of intuitive idea that somehow it's going to make, talking about geoengineering, researching it, is going to make the prospects for ethical action, if you like, on climate change worse. So I'm a little nervous about the argument, and because I'd like to know more about what it's supposed to be. In general, I think there is a worry about moral hazard in the sense that we might create institutions that make it much more likely by their existence that someone will do an intervention. As Dale Jameson said a long time ago, we have sort of a history of creating institutional momentum. If you give money to a big institution to research something, then you create a whole set of vested interests, which is why personally I kind of agree with Alan that probably at the moment we should try to keep geoengineering not as a separate thing that is independently funded, but just as part of the general science research that's done in the country. I do think research should be done, but I'm not at the moment in favor of creating some big special fund that is dedicated just to this thing called geoengineering. Partly, many people agree we don't exactly know what geoengineering is. There's a danger that it is just a funding category rather than anything else. I've forgotten what, I suppose, but on the other hand, I must say I tend to think about the moral hazard argument. We're doing so badly globally with respect to what we should be doing here, that, namely reducing emissions, that in my darker moods, I find it difficult to think we're going to do any worse just because some people have, a few $1 million to try and do some basic research.
Okay, I'm going to go back to questions down the front here. I may try and get back up to the back, depending on how far I push us into drinking time and how much you're willing to agree to that. Here, but let's try and make this round of questions pretty quick.
So, Professor Schrag, you repeatedly stated the anthropogenic forcing equation as greenhouse gas effects minus anthropogenic cooling aerosols, but there's a third significant term. There are a few other terms that are less significant. That third term is anthropogenic warming aerosols. These are commonly called short-lived climate forcers. And if you're making the point that greenhouse gas mitigation leads to a fairly slow onset cooling effect, why wouldn't you start by mitigating emissions of particles that are having a very significant short-term warming effect rather than increasing the number of particles that are having a short-term cooling effect? Okay. Why is this almost never included in discussions in geoengineering on mitigation?
Hold that thought. I'm going to take a few more quickly. Next to you, and then behind you. No, next to you, and then behind you. Thank you.
Hi, my name is Bjornar Egdenissen. I am a PhD candidate at the University of Western Ontario. And please don't take my question as impugning your research ethics, especially since I'm going to meet you after. My question is, since we have one fairly skeptical scientist and one cautiously optimistic scientist, I would call you that, what is the danger of confirmation bias in your research?
Okay, and I'm going to come forward to here.
What about the variability issue about climate change? As an African, I want to know if there are some programs about capacity buildings, about geoengineering. Thank you.
Okay, and right in the front there.
Well, first of all, I'm Jim Anderson. I've never heard you guys be so kind to each other before in my entire life.
It's my influence.
My question is, what did you have for dinner? No. I'd just like to bring it back to this timescale issue that Dan Schrag mentioned. The long timescales we've talked about. The short timescales I don't think we've focused on. Since 2007, 80% of the Arctic floating ice has disappeared. The release of carbon. the loss of the glacial systems for China and for India. I think these short timescales really ignite a battle, and I'm surprised you guys aren't fighting over this.
David, why is there no, I'm going to go with Jim's question first, why is there not more fire in your belly?
I feel like there's been a fair amount since I've been pushing hard, including with Jim, to actually stick our noses way over the transom and propose a specific stratospheric experiment that we could execute. I want to answer the confirmation bias one, can I?
Sure.
I think it's crucial. So I think you can't avoid it. The psychological evidence is overwhelming that these biases where people tend to confirm what they already know are very strong. But I think there are systematic ways you could think, and it's one of the reasons I think we do need a research program, is you can think of designs to try and minimize it. Not within a person, but there are designs to do it. One is to do this kind of red team, blue team thing where you have groups of people whose job it is to try and find all the things that are wrong. The other thing you can do is avoid having a kind of single integrated program, because those things inevitably have ways in which there's a set of thinking that is tends to be uniform in them, so you can think about deliberate ways to break it up. There are lots of individual tricks one can find in Danny Kahneman's book and others that try and, even in research teams, break this down by getting people to answer questions as independently as possible and trying to find ways in which we do fall into those things. So I think in research it's crucial to think about this, and I think there are lots of research designs that allow us to do better, that you can't eliminate it.
Okay, Dan, you asked about short-lived climate forces and soot in particular, I think.
The term that's now in vogue is SLCP, short-lived climate pollutants. And that includes, by the way, not just warming aerosols, but also short-lived greenhouse gases, which includes methane and HFCs. And I'm actually just have something that will come out in Science soon with Ramanathan from Scripps and Mario Molina on this subject. It's interesting because it actually mirrors this discussion exactly, which is that there's a huge debate. First of all, there's a lot of attention to black carbon. So don't suggest that we're not paying attention to it. There's actually, I would think right now, the pendulum is swung to paying maybe too much attention to black carbon. The reason I would argue that is that while there's no question we should reduce black carbon, that's good. It's a bit of an issue. You should also reduce sulfur for pollution, but that, of course, has a big warming effect, and so there's a little tension there. Fundamentally, though, the concern is that if you pay too much attention to black carbon and you take away attention from CO2, what's interesting is it's in the long run, it's CO2 that matters. And so ultimately, and you can look at this with various curves, if you deflect attention from CO2, people argue it's a moral hazard argument. It's exactly identical to saying if you deflect attention by focusing on geoengineering, you take attention away from reducing CO2 emissions. That exact argument is playing out between the SLCPs and CO2. And the answer is you should do both. And guess what? In a real world, it's often hard to do both. So currently the State Department is putting out a big new program to try to reduce SLCPs. And there is a concern that they're going to lead with that program in the climate negotiations, which will take pressure from them because they can say, look, we're doing something, we're focusing on the SLCPs. President Obama had signed an agreement with China to reduce HFCs. Does that take political pressure off them to reduce CO2 emissions? Maybe a little bit. That's a real worry, and that's exactly analogous to the sort of situation we're discussing.
Alan,
is quick.
Yes, it's quick. It's quick, but it also doesn't. You get the same thing. If you did that reduction 100 years from now, you'd get the same benefit. With CO2, it doesn't work that way because the effort you put now reduces emissions that integrate over centuries to millennia. So you actually, if you delay reducing CO2, you end up with more cumulative CO2 in the atmosphere and you end up with net higher warming overall. So
Alan,
that's a big worry.
Would you like to come in on the capacity building, or David, the question about building capacity for research in developing countries?
I went over the list of students at the summer school here, and I was really impressed with so many students from Africa and from developing countries who are getting involved. It's not just geoengineering, though. It's science. It's in general. So you have to have the background in math and science so you can do the research, and that's really important in developing countries for all of science, not just for the geoengineering.
Okay, I'm going to take a last round of questions, starting. Sorry?
Something I probably should have said.
Sorry? Yeah.
Did you mention the summer school for?
Yeah, sure.
Yeah, I realize we maybe should have said this as an introduction. So a big chunk of the audience members are here, and some of us are here, and the reason this was convened is part of the fourth interdisciplinary summer school on geoengineering, and I'm one of many people who have been involved in making this thing go at alternate sides of the Atlantic. And the idea is to get a lot of young researchers in and as much as possible have them run the show. So we had all-day session of briefings about how this thing works and doesn't on Monday, and none of us older folks stood up or even controlled the agenda. But in the extent that we do control the agenda, one thing we've tried very hard to do is deliberately fund and work to make sure we try for a good diversity of discipline and of region. And I think that is exactly because we like to do some capacity building.
Okay, question there. Let's see hands. Okay, I'm going to go with people who I'm not seeing at the summer school. I'm going to go with you and guy right up at the back. So that's 3 people. Please.
Hi, Shana Berlin, an EAPS grad student here. So far, you focused mainly on solar radiation management, which is a specific subset of geoengineering to reduce incoming solar radiation. However, there are other climate effects from greenhouse gases, such as ocean acidification. What opinion do you have on geoengineering proposals that would help mitigate those kind of effects?
Okay, and if we can get the mic moving quickly up towards you. I saw a hand up there.
Andrew.
No, I was ignoring Andrew because he's going to get a chance tomorrow morning. I was going for people, yeah, you, and then you, and then you.
Hi, my name's Raphael Dumas. I tweeted this question twice as fossil-free MIT hashtag, but
oh right, sorry,
didn't
missed it.
Up.
Okay.
With the mention of kind of acute triggers and certain people seeing more benefits to themselves and less kind of disbenefits to themselves. How do we prevent certain countries, companies, millionaires who want to dump a bunch of iron into the sea? How do we stop them from kind of carrying out their own experiments or global programs in geoengineering?
Okay. Yes, you.
Hi, I'm an undergrad at Harvard College. My question's somewhat similar to the person who asked before me. There was this debate about ethics being how important ethics are in the climate debate itself, and I was wondering, Professor Schrag mentioned that we need to think about the effect on the intermediate timescales because we won't be able to see what's happening right now. So, in the political sphere, how are you going to influence or make political leaders realize that this is, or make them acknowledge this as an issue and act positively towards it if it's actually not going to be affecting anyone until our great-grandchildren's generation, which means that it actually just does become an ethics issue. You would want to work towards, work positively against global warming because it seems ethical to do so, but it doesn't actually affect anything right now.
Okay, and right up at the back.
I have a question related to the one before. I'm curious how your research fits in with the UN Convention Against Large-Scale Weather Modification, the one that was passed in, I think, 1978 and ratified by the U.S. in 1980. And even if it does fit that, the reason that convention was passed is that as soon as serious efforts began for large-scale weather modification in the 1960s and 1970s, there was an immediate fear and a kind of international panic that what you're going to see is something being weaponized. And this was seen, I think the U.S. did some stuff in the Vietnam War climate change efforts in Southeast Asia.
Okay. And actually, I feel so guilty about having singled out Andrew for not asking his question, so I'm going to ask Andrew to ask his question as well.
Oh, wait, the mic will
just shout.
Yeah. If forgetting everything else that we could or couldn't do in global warming, should we use solar radiation management just to remove the effect of the carbon dioxide that's been emitted by the world from the start of this lecture? Just that on its own, should we do that in isolation? And if we don't, if somebody else did it, should we ask them to stop?
Okay, that is a great question. I'm going to stop. I'm glad we are. I'm going to ask people to come back to whichever of those questions they choose. I might prod a little bit, and also to sum up as they do so, since we're trespassing on the time of the audiovisual people, among others. Dan.
Well, I actually think that last question is a very interesting question. Let me phrase it a slightly different way. Suppose we actually decide that air pollution matters and we're going to try to dramatically reduce sulfur emissions from coal burning, which, by the way, we need to stop anyway because we need to stop burning coal. But let's suppose we do that. We're going to potentially, if climate sensitivity is higher than we think and the effect of sulfate aerosols is higher than we think, it's on the high end of the errors, of the uncertainty, we might see a dramatic warming for that reduction in sulfur emissions from the troposphere.
And ship tracks too.
Yeah. Currently, sulfur in ship fuel is a big thing. Coal is really big. And so you could imagine, what about an alternative proposal that said, you know what, let's just trade off, as we reduce sulfur in the troposphere, let's trade off a tiny amount of sulfur in the stratosphere just so that we don't actually lose ground on the climate, because we could experience a dramatic warming from trying to reduce sulfur pollution. Does that seem a little more palatable to people? You know, basically replacing pollution we're already doing, reflecting sunlight, with an equivalent amount of stratospheric pollution, except a much tinier amount for health.
Exactly. So
much tinier amount, by a factor of 10 or 20 or something. So that's an interesting way of thinking about it. I think it's an interesting thought question. I want to leave, though, with one really important thing that's depressing. But I've taught a course for many years. I know at least one of my students is in the room, where you try to actually calculate what a low-carbon economy looks like. And I've done it for the world, but just take the US for a second. Just try to do it for the US, making incredibly aggressive assumptions about energy efficiency. And the answer is that with perfect economics, perfect politics, perfect technology, all the political will to decarbonize, at current rates of construction of electricity plants, because the general strategy is to electrify things and then decarbonize the electricity, we're talking about something like 250 years. Now, you could accelerate that. If we built things at the rate of China, it might only take 75 years. So the idea that we can decarbonize quickly, I would just say it's not impossible. I can't tell you that it's technically impossible, but if you look at the rates of industrial requirements and the rates of construction of hardware, it's not like giving up smoking. It's not like some of the other things we're dealing with. We're talking about infrastructure requirements that are massive, and the timescale is, at China's rates of construction, close to 100 years. At our current rates of construction, 200 to 300 years. That means that climate change is going to get a lot worse before it gets better. And this moral hazard issue, to me, you know, frankly, we got to push for reducing CO2 emissions, but we're going to put a lot more CO2. The world's going to put a lot more CO2 in the world, and we better figure out what we're going to do about it.
And is that also, in effect, your answer to the question about intermediate timescales and about political action?
Yeah, that's right.
Alan.
I'd just like to answer the question about ENMOD, the Environmental Modification Treaty, and weaponizing this. On my original list of 20 reasons why it might be a bad idea, those were two of them. One is that it would violate the UN Treaty on hostile environmental modification, and the other is that they could be used as weapons if you develop the technology. Jim Fleming, professor at Colby College, has a great book called Fixing the Sky, which has the long sordid history of weather and climate modification in the world and in this country. It's been attempted for a long, long time. But our research doesn't violate any of this because the ENMOD has to do with actually implementing it, not studying it. Now, there is an issue with small-scale outdoor experiments. What governance do we have about somebody flying a plane up and spraying some stuff out and seeing what effect it would have, or brightening clouds over the ocean? There really is no governance about that. On what scale should it be allowed? Should there be, as David said, red and blue teams, should there be separate people that are evaluating these things? There is no such governance. That's one of the things that has to be built, some way to regulate even small-scale experiments, let alone implementation. ENMOD has never actually been used, and so there's a lot of other international conventions that could be considered. But there's a nice appendix in the Solar Radiation Management Governance Initiative report about that. So it's not clear it would work if somebody tried to say, what you're doing is hostile to me because it's ruining my crops. It's not clear how well it would work, but it is there, and it's something to consider.
Because intent matters, right?
Intent matters, yeah. And how do you know what intent is?
And Alan, while I've got you, I just want to resurrect Jim's question about fire in the belly and about, the ice is vanishing, the glaciers are going. Do you feel that your position here is reflecting that urgency that Jim was bringing to the conversation?
Well, going back to one of the other questions, my biggest concern about the planet is nuclear weapons. And we've got to get rid of them so we have the luxury of worrying about global warming. I mean, if one country attacks another and there are fires, the smoke would go up and cause much larger climate change that we're talking about now. And it's a much easier problem to solve than global warming because there's only about 5,000 nuclear weapons on the planet. So that puts fire in my belly. And yesterday was the 68th anniversary of humans dropping bomb on Hiroshima. So that reminds us about that. The direct effects. The indirect effects will be much worse.
Well, it's nice to know that that's the easier problem to solve. David, preventing millionaires from doing weird stuff. And also, if you want to give a moment's attention, I don't think we're really basically going to get to the non-solar methods. Let's just say that everyone heard that, and it's an important issue, and it's not quite this debate. So I'm going to take us off that hook.
Talk about it afterwards.
Yeah. David.
I want to answer first really on this. I think I was the one who introduced moral hazard into this debate. And I think there's deep confusion here. I think that there are real moral consequences that we in the rich world are imposing damages that are real in this and the next generation that will fall most in the poor world. One of them, not totally clear, is that heat stress on crops will decrease agricultural productivity in ways that matter. There will be other changes that are known and visible, of the kind that are amplified in the way that Jim Anderson is pointing out. And it is by no means clear from the current science that doing the kinds of crude geoengineering we're talking about now is a good thing, but there is strong evidence from the same suite of climate models, the same sort of deep understanding of the atmosphere that we built over a century of science, that doing a little of this would reduce risks for generations of people actually living now. And that doesn't mean it's a slam dunk that you do it. But in my view, it means that you should take it seriously. And taking it seriously does mean building serious research programs that deal not just with the science, but deal more broadly with the social science, that begin to think about architectures of governance and begin to do outdoor experiments, because that's the only way you really find how nature surprises. Not that you can be sure that you'll find them, but you can be sure that if you only work in your computer model, you'll be blind to many of the surprises that nature has in store. And to do that, we need urgently, to get to that last question, to think hard about how to do governance of these. It cannot be that it's individual scientists rushing off with billionaires' money to do things. And to be clear, since I'm associated with that, we have been absolutely clear that we will not do it. And we have no such intention. And indeed, in an article we had in Science recently, Ted Parson and I proposed specific ways that you could begin to do that governance, some of which are executable very quickly. And so to end on that, there's often an idea that all of this needs to be done in some UN way and takes international cooperation, heads of states very far away. There are simple measures you could accomplish in the next year that would begin to sort out these governance questions and actually make it easier to do what I think would be legitimate research in a useful way. And that would be simply for some major science funding agencies in a couple of major developed countries to issue a non-binding memorandum of understanding that just lays out some clear principles about transparency, about how risk assessments be done, about independence. And even though those things were non-binding and those are not a substitute in the long run for stronger regulations, they would have an enormous influence around the world and beginning to help us think clearly about the kind of guidelines we want to allow us to begin to learn more about how well this works or doesn't.
Thank you, David. Stephen.
Okay, let me just say a little bit about the how to influence political leaders and the worry about ethics. And I'm going to be echoing a few things that David just said here. I think a major issue we face is we don't have, or it's certainly very far from clear that we have, the kinds of institutions that are well equipped to deal with the kind of problem we face here, a major global intergenerational and ecological challenge. And of course, as I've emphasized, I'm especially concerned with the intergenerational element here. So I'm not clear that the problem is best posed as saying how do we influence political leaders, meaning the leaders of current institutions that we have that weren't really designed with this kind of problem in mind. There's another level, though, at which the ethical values matter, I think, and that's how do we rouse ourselves to try and make progress in putting in place such institutions for climate in general and maybe geoengineering in particular. And there is a question about the role that ethics could play. Some people in ethical theory do have a view, which is a little like some scientists' view about science, that if you just tell people what the ethical stuff is or the scientific stuff is, and you just keep telling them clearly enough, then they will automatically see what needs to be done and act. Right? I don't hold that view about either ethics or science. I think it's perfectly possible for somebody to see what the ethical truth or the scientific truth is about a problem and yet not be moved, or at least not moved enough. When that happens, we have technical ways of referring to people. I think they're bad. But it's quite possible that people are bad and that our institutions are bad and that we won't be able to fix that, or at least fix it in time, in my view. It's possible, right? And that provokes a title of a paper I have called, Are We the Scum of the Earth? Right? It's possible that we might turn out to be the scum of the earth, I think. But the flip side of that, the more optimistic side is, I think actually most of us, maybe not all of us, but most of us don't want to be the scum of the earth. And it matters deeply to us not to fall into that category. Yes, partly because we care what future generations will think of us and what current generation of the world's poor, for example, might think of us, but also because we care about what we think of ourselves in relation to this problem. And I think that is a powerful and underexplored form of motivation that's at stake in this debate. So that's in some ways more of a promissory note than a real answer, but it's a beginning of an answer to, a personal answer to this question of how to influence what's going to happen here. And I intend it in part as a defense against the deep skepticism we're all encouraged into, which says that people really only care about what happens in the short term and they only care about their narrow consumption benefits and so on. I think we care about some things more deeply, that are more deep than this, and I think that this kind of issue brings them out.
Thank you very much. I was going to say that that we saw evidence of that tonight, and that people gave up their evening and the other things they could have been going to come to this. But of course, the present consumption of this debate was also actually rather pleasurable. So we can't. You'll have to do more in order not to be scum than just to come to debates as good as this. It remains for me to say that the exits are no longer fire exits; they are now the doors to the drinks. Use them wisely, and to thank our panelists for an excellent discussion. Thank you very much indeed.
And can we also thank Oliver Morton for being an excellent moderator. Thank you, Oliver.